Welcome back. Today we're gonna discuss about Unit 10, Trigonometry. So this is grade 12 Mathematics, Unit 10, under the CAP syllabus. So we're gonna do ratios, identities, equations, and angle formulas. So we're gonna revise the Chashotao and the quadrant signs. We're gonna use reduction of formula and cofunctions, simplify and prove trigonometric identities, then solve trigonometric equations, then apply compound and double angle identities. So, for example, this is an example of an identity: sine squared plus cosine squared is equals to 1. So as you can see on the graph here, when you plot it, it will give you this line, which is equal to y is equals to 1. So as you can see on this graph, so for all values of this angle, you can see they will be always equal to 1. So the graph is a horizontal line at y is equals to 1. So if you plot these points, you substitute for theta, the angle, for 0. So sine squared 0 plus cosine squared 0 is equals to 1. So you can use a calculator, then this can be proven. So I see that this is what we are going to cover in this section. So let's move on. So in this unit, the learning map, so the unit 10 builds from triangle ratios to more complex equations and identities. So what we are going to do for step 1, we're going to do ratios. So sine, cos, and tan in triangles, and also on the Cartesian plane. So we're going to also deal with angles. They're going to be special angles, casts, which is on the Cartesian plane, reference angles, and the reductions. So special values, you are looking for angles like 45 degrees, 30 degrees, 60 degrees, 90 degrees. They've got some special properties in triangles. Then under identities, we're going to look at quotient identity, Pythagorean identity, and proofs, where you're going to prove whether the identity is valid. Then we're going to look at equations. So general solution, factorization, and quadratic forms. Then on the formulae, we're gonna do compound angle, double angle, and undefined values. So the general exam principle is choose the identity or a formula that matches the structure of the expression. So as we go along, you discover there are different types of identities that can be used to solve. So obviously you have to choose the appropriate formula or identity that is applicable to the situation that you are dealing with. So let's move on. So let's start with the right angle triangles. So for the right angle triangle, we use this abbreviation Chashotao. It links an angle to the side length and the right angled triangle. So for example, this is your right angle triangle. So this is the opposite, adjacent, and hypotenuse. So if you are looking at sine, you know that it's opposite over hypotenuse. So that is the show. You understand? Then you know opposite over hypotenuse. Then when you look at the cosine, is the char, which is adjacent over hypotenuse. So if you look at tan, is tau, right? It's opposite over adjacent. So that's how the abbreviation works. So so you must keep this Chashotao. Then use only when a right angled triangle is present, or when the right angle triangle can be formed. So it only works. So if there's no right angle, then this formula doesn't apply. It's only useful when you're dealing with right angled triangles. Let's move on. Trig ratios on the Cartesian plane. So for a point which we are calling xy on the terminal arm, r is the distance from the origin. So r is the distance from the origin. So remember, we already spoke about the circle geometry, where we said x squared plus y squared is equal to r squared. So that's where the square root of x squared plus y squared comes into play, as you can see here, which is the hypotenuse and opposite, and this is your right angle here. So what we are basically trying to say is just to draw it on a different so we are saying this is the angle, and this is r, and this is y, and this is x. So when we are saying sine, this is theta, sine theta is goes to opposite of adjacent, which is y, x. Then cos theta is adjacent over hypotenuse. Remember the show tau. So cos is adjacent over hypotenuse. So this is your adjacent and the hypotenuse, which is x over r. Then tan theta is equals to opposite of adjacent. So this is the opposite of adjacent, which is y over x. So this is how we get there, and here we are using the equation of the circle. So that's basically what we are talking about. So this is something to remember, trig ratios on the Cartesian plane. So let's move on. So signs in the 4 quadrant, we use the cast. So we start from so the cast is you can see here is cosine, O, sine, and tangent. So this is the C, the A, the S, and the T. So that's where the cast comes from. So in this first quadrant, all are positive. All are positive, which means cos, tan, and sine, they're all positive. But on the second quadrant, it's only sine which is positive, and the others are negative. On the third quadrant, it's only tan which is positive, and on the fourth one, it's only cos which is positive. So that's what it means. So remember, when you're measuring the angles, we normally measure going this way, right? That's what we mean, right? So remember, the reason why this happened is because if you plot, let's say start with sine, it will be more like this. So we know that this is 0 degrees, this is 180 degrees, this is 360 degrees. So what basically we are trying to say is when it's sine, this is sine, right? When it's sine, from all values that you get, so sine, so remember here it's 90. So from here to here it's 90. From here to here it becomes 180. So as you can see, from 0 to 90 is still positive here. Then from 90 to 80 is still positive, right? But once it goes above 180, it's now at the negative. So remember, here it will be plus 1. Then here it will be negative 1. So once it's below 180, all these values will be negative. That's why it's negative here, here. That is why it's negative here and here, right? But for the same graph, if I change the color, I will have for This will be like for cosine.